Hey everybody, this is Mr. Beckstrom, and today I wanted to do a video. This is on section 6.3. It's question number 1 in the homework, and it says, use the general slicing method to find the volume of the following solid, the solid with a semicircular base of radius 2, whose cross sections perpendicular to the base and parallel to the diameter are squares. Alright, so if we look at the general slicing method here, we'll see that this says an object extending from x equals a to x equals b, but this specifies that the cross section of the solid is perpendicular to the x-axis. So that's going to be a little bit of a clue on how we do ours, and it has the area given by the function a. These are the cross sections that have that area, and it's integrable on the interval a to b. And we have this volume function. So the first thing I always like to do is I like to draw what this looks like here. So I'm just going to draw a little bit of a makeshift graph here. I should probably use the ruler tool is not there yet. All right, so I'm going to do the best I can to do, and we have a semicircular base here, and this is going from -2 to +2, because it has a radius of 2, so to +2. And this here says that the cross sections are going to be parallel to the diameter. So if this is the diameter right here, we're looking at cross sections that go across like this. So the actual formula has them going perpendicular to the x-axis. So we're going to have to change our variables from in terms of x's to in terms of y here. So the first thing is, what is this distance across here? Well, the upper half of a circle, well, let's go ahead and start with the circle. So we have the circle, that's x squared plus y squared is equal to the radius squared. So that's 2 squared. And now, remember, we want to get this in terms of y, so we want to solve for x. So if we subtract y squared from both sides and take the square root, we're going to have y is equal to the square root of 4 minus y squared. And that is going to be the actual distance at any point between y is equal to 0 and y is equal to 2. Remember, it says a radius of 2 of the distance across. Oops, let me not do the whole thing. Only across from here to here. Again, excuse my non-straight lines. The ruler tool is now gone. All right, but we want to find the entire thing across. So we're going to end up having to multiply that by 2. So let's go ahead and do that now. So this is x is equal to 2 root 4 minus y squared. And let me give myself a little bit of room here. And that's going to be the side length of this. Imagine the square coming up, and the area of a square is just its side length squared. So our area function here is just going to be this function, 2 root 4 minus y squared, quantity squared, and that's just going to be equal to 4 times 4 minus y squared, which is going to be equal to 16 minus y squared. So this is our area function here. And now we want to plug that into the volume. So we're going to have the integral. Remember, we're going along our y's because we're going up this semicircle. So we're going to go from 0 to 2. And we're going to have 16. This is the area of all of those squares that are parallel to the x-axis here. So 16 minus y squared dy. And this should give it to us. So once we take the antiderivative, that's going to be 16y minus 1/3 y cubed evaluated from 0 to 2. Now, luckily, if you plug a 0 in there, it's just going to 0 out. So we only have to put the upper limit in there. So let's go ahead and do that in our calculator. Make that a little smaller so I can see both here. So I'm going to do 16 times y, which is 2, minus 1/3 times, should that have be, oh, I'm sorry, this is a 3, isn't it? Yes, because y cubed over 3. Excuse me for that. And that's minus 1/3 x, or in this case, 2 cubed. All right, and that gives us 16 over 3 is our final answer. So that is the volume of this object, as we have squares going parallel to the x-axis and going all the way from y is equal to 0 all the way up to y is equal to 2. All right, if you have any questions, please let me know, and I hope you have a great rest of your day. Thanks.